So now we'll move on to Jim Reuter, our Associate Administrator for Space Technology Mission Directorate, and looking forward to what you have to say, Jim. Thank you.
All right, thanks, Jake, and thank you for inviting us here. And I really want to wish everyone a good morning and appreciate you being here and participating. Could I have the next chart, please? I'm going to talk about, kind of as a way of introduction into what we do in space tech. We kind of divide or think about our strategic investments in two major categories: exploration and commerce. With exploration, we strongly support our human and science mission directorates exploration activities. Of course, focusing on lunar landings and sustainable presence on the moon, and then Mars forward. At the same time, it's equally important for us to focus on commerce and investing in a growing space economy. And when we can put these two together, then we can really have a strong program. Next chart. At a high level, this is our portfolio. One thing about I always talk about is the strength of us is the breadth of our portfolio. We have programs and activities that span from very low technology readiness level to mid, in the laboratory, and high, and including a number of flight demonstrations. We have something like 140 flight demonstrations in work. At our early stage, we have programs for our research grants from the universities, in-house activities for Center Innovation Funds and Early Career Initiative, as well as advanced concept studies, our NIAC program, which is open to everyone. We run tech transfer for the agency. We do most of the prizes and challenges for the agency. We run the small business innovative research programs for the agency. Our technology maturation mid-TRL levels, our game-changing development, and we're going to talk a little bit about our Lunar Surface Innovation Initiative, which is not a program per se, but it's an initiative that we've introduced and is going extremely well. And then our technology demonstrations, including suborbital flight opportunities and small spacecraft and so on. And when you look at it over the last 10 years, especially with our flight opportunities, we fly something in space or suborbital about every 3 weeks for the last 10 years. Next chart, please. Here's kind of a chart that I tried to boil down and talk about our strategic framework for our technology investments and how it relates to our presence on the moon and onto Mars. We view the moon as a great proving ground for us to demonstrate technologies nearer term that helps a sustainable presence on the lunar surface, hopefully help grow a lunar economy, but also then feed forward to Mars. But for us, we've kind of established a strategic technology framework that we guide our investments, and we have 4 strategic thrusts that we use to help guide those things, and they're listed across the top there. Rapid, safe, and efficient space transportation, which we call GO. Expanded access to diverse surface destinations, which we call LAND. Sustainable living and working farther from Earth, which we call LIVE. And then transformative missions and discoveries, which we call Explore. So if you want to know our strategy for investments, it's Go, Land, Live, and Explore. From those thrusts, we develop outcomes that support our customers, both in the commercial side and science and in human exploration. As well as gain inputs from industry as we're going forward. We've taken those outcomes and then identified it's around 14 or so key technology capability areas. They're shown there in the circles and color coded to match the thrust. And those are things that we're working on, and several of which goes and we utilize the moon for a proving ground for us in a test bed. Things on the moon. Examples are precision landing, which we're helping a number of CLIPS providers, as well as potentially further on. And cryogenic fluid management is something that's a cross-cutting activity that we have a large investment in. And there's advanced habitation and autonomy. And what I'll say is when it comes to human life support and habitation systems, when it becomes mid-TRL and higher, it's HEO's responsibility, but we support them with lower technology readiness. And in this, then There's a number of technologies that actually are needed to go to Mars, like advanced propulsion, nuclear technologies, but not really something that you prove on the moon. And I'll just say then there's a number of items in blue of technologies on the moon that form what we call our Lunar Surface Innovation Initiative, and I'll talk about those in coming charts. Next chart. And so, and then as way of introduction to the Lunar Surface Innovation Initiative, the idea behind this is that we work across industry, academia, and government through in-house efforts and public-private partnerships to develop transformative capabilities for lunar surface exploration. We've established this thing. It's been over a year now, and what we did was establish a Lunar Surface Innovation Consortium that you're going to hear about in a little bit later when Rachel Klima from APL talks. And because APL is our overall system integrator for LSII, as well as they lead the Lunar Surface Innovation Consortium. And so we've established 6 focus areas that we focus our efforts around here. They're listed there in the box: in situ resource utilization, surface power, dust mitigation, extreme environments, extreme access, and excavation and construction. And we've worked very hard at engaging the entire community, and we don't reach 330 million that Kathy may have suggested, but in a little over a year, our first consortium full-up consortium meeting was February 28th of last year. We've engaged we now have over 1,000 active participants from 390 organizations across 44 states. And it really is, it's a community, trying to get a community involvement to advance technologies needed to explore the lunar surface in new ways and stimulate a lunar surface economy. And you can see in the pie chart, it's a little small, but we have a really good representation from industry, which is a little over half, and then a nice slice of academia, as well as nonprofits and other government agencies. Next chart, please. And then as my last chart, I just want to talk about, so we've been actively working in a collaborative manner in Lunar Surface Innovation Initiative. And as I said, we're at our strength when we have take advantage of the broad range of STMD programs to establish collaborations across industry and academia and with our sister mission directorates. And just we've listed several of them here that we've done, these are awards that we've made in the last year. First of all, we do run the Small Business Innovative Research program for the agency, and we focus topics on phase 1s and phase 2s. We've taken advantage of the phase 3s in a number of cases to help us. And then also the Civilian Commercialization Readiness Pilot Program and Lunar Sequentials. Those are things, CCRPP has been around for a while, but we've gotten in the last year or so an increased amount of funding available for an individual award. These are post SBR phase 2s, but the CCRP requires a matching funding, and we can go up now to around $3 million a year. And then we established also and got approval for our Lunar Sequentials, and we've made a number of awards here in the last year. I think it's on the order of 10 or so. I don't remember it exactly. But the idea behind a sequential is it's post phase 2 and on the order of $2.5 to $5 million per award. And so it's becoming a way to take advantage of our small business community or expertise to help us and do so in a natural manner in the SBIRs. Our NIAC program, which is really advanced concepts things, but we actually have now a phase 3 award that we implemented for more implementation. And we have an exploration of lunar pits as one of the first awards we've made that we really hope to fly in the coming several years. We have a number of challenges. Our Centennial Challenges is really growing right now. There's 2 large dollar challenges that are related to lunar exploration. One's we call Watts on the Moon, as you might imagine. That's a power distribution concept, and another is called Break the Ice, which, as you might imagine, is to look at concepts for help harvesting ice and turning into water. Those challenges are in a phase 1 that are ongoing right now, and they each have on the order of $505 million or so of potential prize money over the next couple of years. We also use our NASA tournament labs for a number of open source challenges. We're really trying to reach a broad audience with a number of activities. One example of one of those that HeroX, we use the Yet2 capabilities for searching technologies. HeroX has a great collaboration environment, and what they did was through them we had a challenge recently that was that we called "Honey, I Shrunk the NASA Payload." And what that was we've got a number of small rover scouts and potential hoppers going in development to extend our reach. And with those, they can hold a payload on the order of a thick bar of soap. And so what the challenge was, and we ended up with something like 17 winners of different ideas of how you could take advantage of that capability. And it was actually so successful that we established a Honey, I Shrunk the Kids, Honey, I Shrunk the NASA Payloads, the sequel. And so we're developing some of those capabilities even further. Really great way to reach the community that we're having is really exciting. We also have targeted a lot of our research grants in this area. We established over the last year a new, what we call a luster opportunity, Lunar Surface Technology Readiness opportunity. And with it, we picked a number of awards fairly recently that were a little bit larger dollar awards for universities to develop items to demonstrate on the moon, potentially, eventually on the moon. We also use the normal early career faculty and early stage innovation type calls that we have. We have 5 different programs now within our research grants, and so we use the strength of those as targeted opportunities for us. The Big Idea Challenge is a university challenge, primarily university challenge, and with it we had our 2020 was with universities that did a great job on permanent shadowed region technologies. And right now we have ongoing a dust challenge, and we have 7 teams participating there. The bit larger awards that we have for industry, primarily for industry, is called through our tipping point and collaborative, and also our collaborative opportunities programs. We had about 15 overall total selections in 2020, about $120 million value. A lot of that was focused on things that we want to turn into payloads and using the commercial lunar payload services or the CLPS demonstrations, and things like the Prime 1 mass spectrometer and drill looking for water, as well as a Nokia 4G wireless demonstration on the moon, 4G LTE as well, and then intuitive machines that have deployable hoppers. So we've actually are forming some really cool missions, taking advantage of the great service that science has provided and integrating with the science objectives. We also recently had an award, 5 awards for phase 1's studies, design activities for vertical solar array technologies, which would be a telescoping solar array basically on the South Pole to help improve the incident angle and improve the power generation capability. We've had a number of next step BAAs ongoing, 9 award winners for ISRU activities that have been going on for the last few years. And then finally, the APL activity that for integration of our Lunar Surface Innovation Initiative and our consortium. And with that, go to the next chart. I'll turn it back to you, Jake.
Great. Thanks so much, Jim. That was exciting to see all the different activities that are underway in STMD as we move forward.